In 2004, a team of 3 researchers, led by Michael Brown, published a paper presenting the discovery of an object with an orbit that cannot be explained. This object was designated 2003 VB12, otherwise known as Sedna. According to this paper, Sedna's orbit was unlike any object ever seen up to that point. Because of its extremely large and elliptical orbit, it appeared to them that this object may have been perturbed into this orbit by what they described as planets yet to be seen in the solar system or forces beyond the solar system. The discovery of Sedna marked the beginning of a large-scale study of the outer solar system, as astronomers were curious as to why Sedna's orbit is the way it is. Then, in 2014, astronomers Chad Trujillo and Scott Shepard published the discovery of another object with an orbit oddly similar to that of Sedna. It's designated 2012 VP113, appropriately nicknamed Biden. Trujillo and Shepard also point out that a sample of 12 other objects also exhibited strange orbital behavior, in that their orbits pointed in the same direction. This would later be expanded upon by the research done by Konstantin Batygin and Michael Brown, when in 2016 they did their own sampling of the outer solar system, and concluded that in fact, there appears to be something more going on with these Kuiper Belt objects, or KBOs. Using a sample of several objects and orbital simulations, Batygin and Brown report that the behavior of these objects is consistent with perturbations of a 9th planet. Estimates of Planet 9's characteristics have varied through the years. As telescopes have collected more data and algorithms have become more sophisticated, these estimates have gradually been tuned. The most recent estimates come from a study published by Amir Siraj and others in early 2025. According to the data currently available, they estimate that Planet 9 is 3 to 6 times as massive as Earth, with a radius between 2 and 4 times that of Earth. It has an estimated semi-major axis of about 290 AU. For reference, Pluto has a semi-major axis of just 39 AU, with an orbital period of about 248 Earth years. Based on these numbers, Planet 9 is estimated to have an orbital period of around 5,000 Earth years. This may seem like a big number, but consider again the 2 objects mentioned earlier, Sedna and Biden. These objects have orbital periods of approximately 11,400 years and 4,200 years respectively. So although Planet 9 is hypothesized to be extremely far away from the Sun, its orbit isn't like anything we haven't seen. A bit more on Planet 9's mass, which is between the Earth's and Neptune's. Of the currently known 8 planets, none of them fall into this range. However, planets like this have been discovered in abundance orbiting other stars, and they are known as super-Earths. Some well-known examples of super-Earths that orbit other stars are LHS 1140b, located 49 light-years away, which is thought to be an ocean world, and Kepler 22b, located 640 light-years away, which was the first exoplanet ever discovered to orbit within the habitable zone of a sun-like star. And there are many other such planets that exist. The fact that the solar system contains so many planets, yet lacks a super-Earth, makes it quite unusual. As of December 2025, there is no observable evidence for Planet 9, and this could be for several reasons. One major issue is that Planet 9's perihelion is about 200 AU. This means that Planet 9 does not get closer to the Sun than this distance. Detecting objects at more than 100 AU is an extremely difficult task, even with a high certainty of location in the sky. As of December 2025, the most distant solar system object ever discovered is 2018 AG37, nicknamed Far Far Out. It was found at a distance of 132 AU. With Planet 9, astronomers have a general idea in the sky of where it might be, but there is still an element of uncertainty that will make it much harder to pinpoint. On top of that, all of this is assuming that Planet 9 is at perihelion. Planet 9's aphelion, its furthest point in its orbit, is estimated to be about 370 AU from the Sun. If Planet 9 is at aphelion, current technology is simply incapable of detecting it. Despite these difficulties, there are several sky surveys working to create a deep map of the sky to allow astronomers to search through the data and potentially make a discovery. We've seen the case for Planet 9, but this hypothesis has clearly encountered much pushback over the years. We'll take a look at two of the most common responses. In 2020, astronomers Jakub Schultz and James Unwin published a paper that proposed Planet 9 is actually a primordial black hole, or PBH for short. But what is a PBH? A PBH is not a common type of black hole like Sagittarius A star or Cygnus X1, but rather, a PBH is a type of black hole that is thought to have formed right after the Big Bang and populating the early universe. Depending on when they formed after the Big Bang, a PBH can have a mass anywhere from smaller than a grain of sand to hundreds of thousands of times more massive than the Sun. So that's an overview of exactly what a PBH is, but why do these researchers think there could be one hiding in the outer reaches of the solar system? Interestingly, they cite a series of strange observations they received from a telescope known as the Optical Gravitational Lensing Experiment, OGLE for short. The OGLE is a very special type of telescope. It specializes in something called gravitational lensing, which is a phenomenon that involves light bending around gravitational fields, as Einstein predicted. We clearly see this effect in large galaxy clusters, but OGLE works on much smaller scales. Instead, it watches for this effect to happen on stars near the galactic bulge. What could cause this? Free-floating planets, or perhaps PBHs passing in front of stars, which would register as one-time increases in brightness. Schultz and Unwin note that OGLE observed a series of 6 short microlensing events, all corresponding to objects between 0.5 and 20 Earth masses. They argue that these actually suggest the existence of a population of captured PBHs in the outer solar system, and this also serves to explain the orbital anomalies which the Planet 9 hypothesis appeals to. As of December 2025, PBHs are hypothetical objects. They have never been observed and have not been scientifically confirmed to exist. However, if the James Webb Space Telescope can gain some insight, the explanatory power of this alternative hypothesis will only continue to increase. The second alternative explanation we'll look at is a paper published by Catherine Brown and Harsh Mathur in October 2023. Their main argument is that the orbital anomalies seen in the outer solar system can be explained by actually modifying how we understand the physical world. This hypothesis is called Modified Newtonian Dynamics, or MOND for short, and it was initially proposed in 1983 by Mordechai Milgram. MOND was proposed in order to address a long-standing mystery in astronomy, the rotation of spiral galaxies. Spiral galaxies rotate in a density wave pattern, but there is a problem. Stars and matter in the outer regions of galaxies are observed to orbit much faster than they should be able to. Under regular Newtonian gravity, these stars should have been flung out, unless there is some unseen matter in the galaxy holding everything together. This unseen matter is called dark matter, and is hypothesized to not interact with light or regular matter. However, MOND takes a different approach. It proposes that Newtonian mechanics break down at the very weak gravitational acceleration felt by these outer stars, and thus MOND suggests that the gravitational strength reduces slower than Newtonian mechanics suggests. Brown and Mather show that by applying MOND to the orbital dynamics of the solar system, they end up with a model that can actually produce the orbital clustering that was observed in the outer solar system, and all without the need for Planet 9 or primordial black holes. This would be a solid case against Planet 9, if it wasn't for MOND itself being very controversial among the scientific community, and it not gaining widespread acceptance. These are two of the simpler explanations, but there are many more that have been put forward, and many are more complicated. As our technology improves, so will our understanding of the outer solar system, and perhaps it won't be too long before we have a solid answer on the existence of Planet 9.